Sorry about that. Okay, now we're actually going to start. So, what are we talking about today? We are talking about right triangle trigonometry. So, to begin right triangle trigonometry, we remember SOHCAHTOA, right? That's SOHCAHTOA, right? SOHCAHTOA. What does that mean? The sine of theta is opposite over hypotenuse. The cosine of theta equals adjacent over hypotenuse. And the tangent of theta equals opposite over adjacent. Okay? So theta is the angle that I'm interested in. So in this case, the first question is the tangent of r. So the tangent of r, if r is the angle, then which is the opposite side? 5. 5 is the length of the opposite side, and it's over adjacent. And which is the adjacent? Anybody? 12. So the tangent of r is 5 over 12. Simple as that. You don't need to do anything more and nothing less. Got it? Okay. Next thing, it says the tangent of t. So here's the angle t. So the opposite and adjacent sides will be different. So which side is opposite of angle t? 12 is opposite. So it's 12 over, and adjacent is 5. So it's 12 over 5. And remember, class, that the hypotenuse is always the side that's opposite the right angle. And it's the longest side of a triangle. The hypotenuse is always the longest. Okay, and it's always opposite the right angle. Does this make sense? Is everybody with that? Yeah, I'm sorry. I will slow it down. What was that? Yeah, that's number 8. Number 8? I think it's number 8. Right?
Yeah.
Yeah, it's number 8. So it's right triangle trigonometry. And remember, class, all these videos are going in their own playlist that's going to be right on your MyCCA. I've also put up the review packet as a download link on MyCCA, so in case you lose yours, you can just download it again and print it out. Does everyone here have a review packet? Yeah. Okay, got it? Yeah? All right, cool. All right, so moving forward, any questions on this? No? All right. Okay. So next is sine and cosine. Okay. So we go to sine and cosine. Once again, we remember SOHCAHTOA. Okay. And the first thing it asks us is for the sine of A. Well, the sine of A is opposite over hypotenuse, right? Sine of theta is opposite over hypotenuse. So what's the opposite of angle A? 4. Good. And what's the hypotenuse? 5. Good. Will the hypotenuse ever change? No, the hypotenuse remains the same no matter what angle we're talking about. Okay, the next is the sine of B. So sine of B, the opposite side is 3, and the hypotenuse, once again, is still 5. Next, it asks for the cosine of A. So cosine of an angle theta is adjacent over hypotenuse. So the adjacent side here is 3, and the hypotenuse is still 5. And the last thing it asks for is the cosine of B. What's the adjacent side for B? Anyone? 4. Good. 4 over 5. Does this make sense to you guys? Are we with this? We understand this? Some of you guys on the test got confused because I would ask you something like this and you'd think that you'd had to like solve for something or like, no, I'm not asking you for that. There are problems where you do have to solve, but this is not one of them. This is just asking you to remember that sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. Simple as that. Okay? So that's kind of the introductory type of questions. Any questions on this? No. Okay, next. The next question goes into inverse trigonometry. So this question is on inverse trig, but now let's make a little table here. There's regular trigonometry and then there's inverse trigonometry. Okay, regular trigonometry says that the sine of theta is opposite over hypotenuse. Inverse trigonometry says that theta is the inverse sine of opposite over hypotenuse. You guys remember this? We use inverse trig to solve for theta. If we're asked for the measure of an angle, we use inverse trig. Does that make sense? Yes. Okay. Cosine of theta equals what? Adjacent over hypotenuse. So theta equals inverse cosine of adjacent over hypotenuse. We'll go over that in just a second. Tangent of theta is opposite over adjacent. Theta, inverse trig, says that theta equals inverse tangent of opposite over adjacent. You guys see the pattern? You understand here? Yeah. Okay. So it says find the measure of angle C. Round to the nearest tenth if necessary. So we're looking for angle C. And the first case says AB is 3 and AC is 4. Well, the question is, in terms of angle C, what are these sides? 3 is what? Opposite, adjacent, or hypotenuse?
Opposite.
3 is opposite to the angle, you see? 4 is what? Adjacent. Okay, so we have the opposite side and the adjacent side, so which should we use? Tangent. So we get theta equals inverse tangent of 3 over 4. Okay, so we pull out our handy dandy calculators, and remember class, you're going to need your calculator for the final exam. Okay?
Don't forget it.
You're going to need it for your final exam. Inverse tangent, and you should probably start bringing it into class so you start remembering how to use it. Theta equals inverse tangent of 36.9 degrees. Or I'm sorry, theta equals inverse tangent of 3 over 4, which is 36.9 degrees. Got it? Gosh, those fidgets, man.
It's actually giving me more anxiety, so.
So, yeah, stop. Thank you.
Totally.
D plus
I feel like it's
tangent,
gonna, like-
second.
Yes?
What do you push on the calculator?
Yeah. In your phone,
For cosine. For like inverse.
your calculators will do it like this. Shh, everyone watch, because most of you have calculators like this. To do the inverse tangent, look at me. Look, you do second tangent, and you see how it says inverse tangent right above it? Above the tangent button? So you do second tangent, and then in the parentheses you do 3 divided by 4, close your parentheses, it equals, okay, 36.9, okay? And the only thing is you have to make sure you're in degrees, okay? So if you're confused of whether or not you're in degrees, make sure you bring your calculator in and I can check it out for you, because sometimes calculators are different in how they change it. All right? Any questions? Okay, the next one then says that AB is equal to 5 and AC is equal to 9. So it's still opposite and adjacent sides. So theta, I'm still going to use what? Inverse tangent. Inverse tangent of opposite over adjacent is 5 over 9. So I go into my calculator.
Did you get like really quiet or something? Did the air turn off? Oh,
Yeah.
that's so scary.
Equals 29.1 degrees. Okay. It's okay. It was getting too cold in here anyway.
But it's just like a weird quiet. Don't like it.
It's kind of nice as long as you just like allow yourself to not fidget with that.
I'm
It's like everything's nice and quiet, and all you hear is Rasheen like.
Oh my, like just thinking about that is making me like, oh, I don't want that. This is being recorded. This is
You know that's why little children. It's good to have white noise for like little babies.
I need that.
Helps them to sleep. Okay. Any questions about this inverse tangent? No? Okay. How you doing back there, Jamie? You with me? Solid? You rocking through this with me? All right. Jackie, how you doing? Praise the Lord. Amen. All right.
I'm not doing well.
Who? Are you sick?
Oh my god, I'm dying.
Well, we're all dying.
No,
Why would
I
We already went over that in this class, I'm pretty
No.
sure. We didn't
we
we?
didn't go over anything in this class other than math. That's true. I'm not kidding.
I'm gonna bypass. All right.
Don't do that either. It sounds awful.
Just do it.
Don't have bypass.
No. Yes, you may. All right. Calculate the following values for the triangle RST. Round to the nearest tenth if necessary. Cosine of R. Okay. Look. Here's the angle R. Cosine is what? Adjacent over hypotenuse. So the adjacent is 15. Hypotenuse is 17. So the cosine of angle R is 15 over 17. But now look at this. The next thing it asks is the angle R, the measurement of the angle R. Well, if cosine of R equals 15 over 17, then R equals what, class? Inverse what?
15.
Inverse cosine of 15 over 17. You see? Does that make sense?
Wait, why is it inverse?
Because I'm solving for the angle now.
Is it always gonna be like that?
Whenever you're solving for an angle, you use inverse. Okay? So I go into my calculator. Inverse cosine of 15 over 17 is 28.1 degrees. Got it? Any questions about that? Okay. Next, it says the sine of S. Sine of S is what? Sine is what? Opposite over hypotenuse. So it's 15 is opposite over the hypotenuse is the same, so it's 15 over 17. But now look, if the sine of angle S is equal to 15 over 17, then the measurement of angle S equals what? Inverse sine of 15 over 17. Does that make sense? Okay. So 15 over 17, we take the inverse sine of that and we get 61.93 degrees. You understand this? Inverse cosine, inverse sine, inverse tangent. Okay, that was the simple stuff, right? Getting the tangent, cosine, sine, getting the inverse tangent, inverse cosine, inverse sine. We see? How you doing, Ryan? Good with me? Savannah? Uh-huh. You following along in the packet? Okay.
Oh, her notes are on my hand.
Got it. Okay. All right. Everyone else good? Ariel, solid? All right. Joey?
Yeah.
Yeah, good.
What about
Lotta?
rounding up to 62?
What was that?
What about rounding up?
I would probably take off a point.
Really?
Yeah.
It's what?
If you rounded it to 62. It depends on how much work you showed me. If you showed me a lot of work and then I noticed that you had something and then you rounded it, I'd be less inclined to take off a point. But if you just gave me the answer, then
Gotcha.
I'd probably be more inclined to take off a point. You should round to at least 1 decimal point. Okay? All right, next, moving forward. Now you're going to have an opportunity to work on work independently. The next is applications of trigonometry. Okay, so you'll see here that there are example questions that you can look at, but what you're going to do on your own is this question here. Okay, from a point 20 meters away from the foot of a tower, the angle of elevation of the top of the tower is 30 degrees. Find the height of the tower. Okay, so here is the tower. You've got something 20 meters away. That's the 20 meters here. And the angle of elevation is 30 degrees. And they want you to find the height of the tower. So go ahead and do that now. Okay, so everyone should be putting those pencils and pens to paper, including you, Ms. Selke. Thank you, everybody. So I appreciate the artistry certainly I do. Okay, so get crack-a-lacking on that one, please. Yes, ma'am. That's the wrong one, too. I didn't have any points in this one, so I guess I just said. But wait, no, you don't. There's one in the comments. 17. I didn't realize that. Yeah, I realized that when I was grading.
Wait, why did it not work?
My turn is what we played, so I need help in figuring out what one more thing is. Because if I turn there, when I grade for outside,
Wait.
4 homework I have.
It's 60 points. What am I going to say? Well,
Oh, is it because I
I
have?
don't know. One of the homeworks is this one's my fault. But I didn't see another homework.
Wait.
All right.
Okay, no.
Yes.
For this, I did sine inverse 15 over 17. I got that.
What are Oreo cookies at?
All right. Let's take a look. You guys finished? Savannah, how you doing? What's the answer? I know. I'm just picking on you. Okay. It's just because, we chastise those we love. And I love you all. All right. Now, shh. From a point 20 meters away from the foot of the tower, the angle of elevation at the top of the tower is 30 degrees. Find the height of the tower. Now, class, shh. This is x. Now, if that is x, how do I solve for x is the question. Well, let's see. I've got an angle here, 30 degrees. This side, 20 meters, is what in relation to that angle? Adjacent, opposite, hypotenuse? Adjacent. X will be what? Opposite. So I have opposite and adjacent. So what are we talking about here?
So, sine. Opposite over adjacent.
Tangent. Tangent is toa. So ka toa. So ka toa. Toa, tangent is opposite over adjacent. So the tangent of the angle, 30 degrees, equals opposite, which is x, over adjacent, which is 20. What do I do now? What do I do now? What am I solving for? X, which is what? in terms of this word problem? X is the what?
Height.
The height of the
The tower.
tower, right? That's what I'm solving for. So if I want to solve for x because I'm trying to find the height of the tower, what do I do?
Multiply by 20.
Multiply by 20. And I end up with x equals 20 times the tangent of 30 degrees. And the tangent of 30 degrees is radical 3, which in decimal form, sorry, not radical 3 over 3. Tangent of 30 degrees is 0.577. 4. Keep that in my calculator, multiply it by 20, and I get 11.55. So I solve for x. X is 11.55. What does that mean in terms of my word problem?
Height.
The height of the is 11.55 meters. Very good. So that is my final answer right there. Got it? 11.55 meters is my final answer. Any questions on how to do that? There's for sure a very high likelihood that a question like that will be on this test. So it's important that you understand it. I can do one maybe another time. Yes, you may. Okay. Now we're moving forward. Wednesday morning at 8:30, I believe. What's after that? I don't remember.
Try social studies.
Social study? Oh, wow. I missed the first one.
I'm taking Howard Tuesday. At 9:30.
Okay. Shh. All right. Now class. Shh. We're bringing it back to the beginning of this semester. Central and inscribed angles. Okay? A central angle in a circle. You guys got to pay attention now. A central angle in the circle has its vertex in the center of the circle. You see? Central angle has the vertex in the center. This is the angle, theta. You see? An inscribed angle has its vertex on the circumference of the circle. That's the angle. You see? Both of these angles intercept what's called an arc. And each arc is measured in degrees, or is measured like an angle. So the question is, what is the intercepted arc in terms of the central angle or the inscribed angle? Well, it is this. The central angle is equal to the measurement of the arc. An inscribed angle, on the other hand, is equal to 1/2 the measurement of the arc. Okay? So the central angle here is equal to the arc. The inscribed angle is 1/2 of the arc. Okay? In order to demonstrate this, let me show you something. Okay? Here's a circle. Okay? Let's say I make a central angle. Where's the vertex of a central angle? Vertex of a central angle is in the middle of the circle. That's why it's called a central angle, right? Central, center. Get it? You see? Let's say I make that angle 90 degrees. Here's my 90-degree angle. Well, how much of the circle is in that arc? that it intercepts? How much of the circle is in that arc? Half of the circle, the whole circle, a quarter of the circle, right? Well, how many degrees are there in a total circle? 360 degrees in a circle, right? Well, 90 over 360 becomes 1/4, simplifies to 1/4, you see? Does this make sense? So look, the central angle, which is 90 degrees, intercepts an arc, which is also 90 degrees. You see? Does that make sense? Okay. But an inscribed angle, and you can kind of see it here, an inscribed angle is only half of that. Okay? Now let's show that. Let's show it for an inscribed angle, because we did it with a central angle. Now let's show it with an inscribed angle. Let's say we make an inscribed angle, and for this inscribed angle, we also make it be 90 degrees. Where's the vertex of an inscribed angle? Is it in the center? No. The vertex of a central angle is in the center. The vertex of an inscribed angle is on the circumference. Okay? So here's a 90-degree angle. Right? You guys agree that that's a 90-degree angle? But wait a second. How much of the circle is in the arc that it intercepts? Is it a quarter? No. It's half, right? So that arc is 180 degrees, right? Because it's half of 360. But the angle isn't 180. The angle is 90 degrees, you see? So the inscribed angle is half of the arc. Can you guys see that? Is that clear? A central angle is equal to the arc. An inscribed angle is 1/2 of the arc. You see that? Any questions about that? Okay. Number 3, the measure of a central angle is 60 degrees. What is the measure of its intercepted arc? $60. A central angle is equal to the measure of the intercepted arc. So if the central angle is 60, the intercepted arc is 60, right? Now, a central angle and inscribed angle intercept the same arc. The measure of the central angle is 60 degrees. What is the measure of the inscribed angle? 30 degrees. I'll show you. I'll show you why. I'll show you why. Give me a second. Let's think about the question. Okay, here's my circle. Here's my circle. Okay, here's my central angle. Central angle, it says, is 60 degrees. So let's draw a 60-degree central angle. That's basically this right here. Okay, this is 60 degrees. Now, guys, focus. The central angle is 60 degrees. Remember, on the final exam, I'm not going to be there to answer questions. Okay? The central angle is 60 degrees. What does that mean about the arc? It's also 60 degrees. Okay, cool. So I learned about that arc. Now, I'm going to draw an inscribed angle that intercepts that same arc. So an inscribed angle that intercepts that arc would look like something like this. You see that, guys? You see that? How that's an inscribed angle that intercepts the same arc? That's what it says. A central angle and an inscribed angle intercept the same arc. The measure of the central angle is 60, so I know the arc is 60. But if the arc is 60, what's the measure of the inscribed angle? 30. Why? Because it's half. Because it's half the angle of the arc. Does that make sense to you guys? Okay, what's the takeaway? Central angle is equal to the arc. Inscribed angle is half the arc. Simple as that. That was because it was 1/2 of the arc. Okay.
Oh, I see.
All right. Any question? Anybody? Going once, going twice? Sold.
Yeah. Shall we sold, girls?
All right. Now, here's a question that I want to hear everybody answer. What is the circumference of a circle? Everyone. Circumference of a circle. What's the formula?
Pi times diameter. And then you just
The circumference of a circle is 2 pi r. Okay. What's the area of a circle? Everyone, what's the area of a circle? Pi r squared. Okay. Circumference of a circle is 2 pi r. Area of a circle is pi r squared. The diameter equals how many times the radius? 2. The diameter is 2 times the radius. Why? Here is a circle. Class, if this is the diameter, then the radius is half of that. The radius is half of that. Okay? You see? Does that make sense? Okay. We clear on that? We've known that for ages. Thank you, sir. Now, yes. Diameter equals 2 times the radius. Circumference of a circle is 2 pi r. Area of a circle is pi r squared. Okay. Now, thank you. Okay. All right. Now, you guys got to pay attention to this. Arc length. Arc length. Sure. Arc length. Okay. Remember, I was talking about the measure of an arc, right? Well, the measure of an arc is different from the arc length because the measure of the arc measures the arc in angles, like degrees, but an arc length measures how long the actual arc is. Okay? So, if I have a circle with radius r, the circumference of the circle, what's the circumference of a circle?
2 pi r.
2 pi r, right? Well, this arc length, you see that arc length, is not the entire circumference of the circle, right? It's a ratio or a fraction of that. It's a fraction of the entirety of the circle, right? Well, how many degrees are there in a circle? 360. So the arc length measured by some central angle theta is theta over 360 multiplied by 2 pi r. So 2 pi r we know is the circumference. But theta over 360 is the fraction of the circumference. For instance, if theta was 360 degrees, right? If theta was 360 degrees, then the arc would be the whole circle. Can you guys see that? If theta was 360, the arc would be the whole circle. Well, 360 over 360 is just 1, so the arc length would just be the circumference, you see? If theta was 180, the arc would be half the circle. 180 over 360 is 1/2, you see? If it was 90 degrees, like what this looks like, if it's 90, that's a quarter of the circle. Well, 90 over 360 is 1/4, you see? So this theta over 360 gives us the fraction of the circumference that the arc length is equal to. Does that make sense? So this is the equation we have to use. Arc length equals theta over 360 times 2 pi r. Got it? Okay. So I'll do number 1. Number 1, theta is 100 degrees. So 100 over 360 times 2 pi, and the radius is 9. So I do that in my calculator. I do 100 times 2 times 9, and then divide that by 360, and I get 5 pi. You see? Okay, I'm going to do number 2. Number 2 and number 3 I'm going to leave to you guys, okay, because I got to move a little bit. Well, guys, go ahead and do number 2, quickly. I got to go fast, so quickly do number 2. Go ahead, everybody. Number 2, the radius is 10. The angle is 90 degrees. This one was 5 pi meters, because the unit was in meters. Joey, have you done number 2? Thank you, sir. I hear you. I love you, Joey. You can do it. You can do it. I feel you, man. I feel you. Hey, it's a part of it, man. Trust me. It's a part of it. It's a part of it.
What?
We're all in it together. I tell you one thing, though. That's for sure. Sometimes it seems like the teachers are just against the students. Sometimes the teachers think the students are just against the teachers. But I tell you one thing. We're all in it together.
Only you.
All right. So, how do we do this? Theta is 90 degrees. 90 over 360 times 2 pi. Radius is 10. Okay? 90 times 2 times 10 over 360 is 5. Multiply that by pi. We get 5 pi. The units are centimeters. So it's 5 pi centimeters. Got it? Okay. I got to move forward because we got to get to our last little bit of material. I'll leave number 3 for you guys to do on practice. Any questions about this, though, right now? No? We feel pretty good? Yeah? Okay. All right. Last thing that we're going through today,
Wait, that's a 5, right?
5 pi. This is something that it really shouldn't be that big of a deal because we spent a lot of time doing this, is sector area. You guys remember that quiz where we found the sector area and we found the triangle within the circle? You guys remember that? The area of the triangle, we used trigonometry to get that. This was the first step of that, just finding the sector area. Okay, what's the area of a circle? Pi r squared. Okay, so let's say this is some angle theta. I'm trying to find the area of this sector here. You see that? You guys remember this? Yeah? Anybody? Yes? Mike remembers it. Thank you, Mike. All right. Finding the area of a sector, it's the same deal as arc length, okay? The sector area equals the fraction theta over 360 times the total area, which is pi r squared. You see? Theta over 360 times pi r squared, it's the same fraction. You guys see this? It's the same fraction, theta over 360, but instead of circumference, now this is the area. Mm-hmm. Mm-hmm. Theta over 360 times pi r squared. Okay, for number 4, we can do this, class, stay with me. Number 4, the sector area. What's theta for number 4? What's theta? 90 degrees, thank you, Ryan. 90 over 360 times pi, what's the radius? 8 squared. So it's 90 over 360 pi, what's 8 squared?
64.
Very good. So it's 64 times 90 over 360 is 16 pi. 16 pi. You guys understand this? All right, I'm going to do one more, and then I'm not changing this. I'm going to keep it up.
Wait, how did you get 16? I didn't pay.
64 was 8 squared.
Yeah, no, I know, 16.
I did 64 times 90 and then divided that by
Oh, okay.
360. So number 5, the sector area. What's the angle here for number 5? 45, good. Over 360 times pi times the radius. What's the radius? 12, good. 12 squared. So it's 45 over 360 times pi. What's 12 squared? Very good. 144 times 45 over 360 is 18. So this is 18 pi, and my units are inches. 18 pi inches. Except it's squared. Why is it squared, class? Am I finding the length of something? It's the sector what? Sector area. Area will always be squared. Right? The units are squared. Right? Volume is cubed, area is squared, distance or length is the first power. One dimensional. Got it?
Got it.
Woo-hoo!
Let's get this one, baby.
Did it. Good job, class. That's it. That's it for our review today. Make sure you guys check out those videos